Now that we've talked about the basic idea of a limit, we can talk about certain limit laws that allow us to evaluate limits more efficiently. So suppose we have two functions, and suppose these two limits, the limit as x approaches c of f of x, suppose that's a well-defined limit, and suppose the limit as x approaches c of g of x is also a well-defined limit. So both of these have values of some kind. Then, first of all, it's true that if we take the limit as x approaches c of either the sum or the product, the sum or the difference of f of x and g of x, if we add them or we subtract them, well, then that's going to be the same thing as taking the limits separately and adding them or subtracting them. So the sum of the limits is the limit of the sum. The difference of the limits is the limit of the difference. Okay, very interesting. If we're taking a limit and we just have some constant multiplying a function out in front, well, we can just take this constant outside of the limit. We can factor it outside of the limit entirely. And so it would be k times whatever the output of the limit is. If we are multiplying two functions, if we are taking the limit of a product, f of x times g of x, well, this is going to be the product of the limits. We can take the limits separately, the limit of f of x, and multiply it by the limit of g of x. And finally, if we're taking the limit of a quotient, f of x over g of x, then this is going to be the quotient of the limits. And of course, the only thing we're assuming here is we're assuming that the limit as x approaches c of g of x, whatever value it does have, we're assuming that it doesn't equal 0, so we have a 0 in the denominator. But those are examples of some limit laws that will help us evaluate limits.